mechanical engineer are called the people who run the world.
Hey guys, we are back with another episode of the STEMPOWER podcast series. My name is Sid.
And my name is Valerie.
Joined with us today is Professor Amirkianoosh Kiani.
So, Professor Kiani, would you like to introduce yourself to our listeners? What is it that you do?
Thank you. So, my name is Kiani, and I am an assistant professor at Ontario Tech University. I'm working in the Department of Mechanical and Manufacturing Engineering. My field of research, is laser nanofabrication. In fact, we are using laser as a tools to manufacture nanomaterials for a wide range of applications, from biomedical engineering, energy storage system, solar cell system, and advanced sensor fabrication. My academic journey was very long and interesting. I got my bachelor in Iran, my master in Ukraine, and my PhD in Canada. 3 different continents, countries, languages, and academic systems. Now I'm here in Canada and teaching mechanical engineering and conducting research in mechanical engineering topics.
Nice, perfect. All right, so let's get right into our first question. So really, there's a multitude of different fields in engineering. So specifically, why did you choose to study mechanical engineering?
So for me, like many other engineers, the love of engineering in general, and especially for the mechanical field, started from my childhood.
Mm-hmm.
One of the most favorite thing in my grandmother's house, I remember, it was her hand power sewing machine. I always got amazed, by looking how it works. And one day that machine got broken. My dad reassembled the machine, and I completely mesmerized with what I was seeing for the first time. A lot of mechanical and moving parts, components that are integrated together to transfer the force and movement, from rotatory wheels to a needle. I never, forgot that moment that I couldn't control my curiosity. Also, I was banned not to touch it because it isn't for kids, but I couldn't control myself. Whenever I had the chance, I wanted to open it, look inside, and later on, during my engineering study, a lot of design projects that I did, to be honest, I inspired with the components, the system that I saw in that sewing machine.
Wow.
The other, things that I really like during my childhood, it was reading. And my childhood favorite book, it was Mysterious Island by Jules Verne. I'm not sure if you heard about that one. This is about a group of people that they got stuck in the island, in Mysterious Island. And my favorite character in that book, it was Cyrus Smith, the engineer. His hands-on experience and his very efficient engineering design, in fact, changed the livelihood of his companions, castmates in the island, completely. So the difference between living a wooden broken shack beside the sandy beach and living in a granite house with the telegraph machine, all those the tools, machine system. I mean, it was kind of very amazing. After reading that book, I said, well, I want to be an engineer. I want to be an engineer because of that character.
That's an amazing experience to have for sure, and I think it's very inspiring to see someone like a father figure like your dad who remade something which could have inspired your career in a sense. So what was your first engineering design?
Oh, my joyful one I can recall now. I remember that I redesigned my school wooden desk homework from a very small, tiny model to a real and practical one that I could use in my room as my study desk for many years, and I was really proud of designing, that special desk with special functions. In more serious work, maybe what I remember as my first engineer design in my career. I work in a company related to the steel mills, and I remember that the air conditioning system that they had for that industrial hall was very old and inefficient. So they gave me as a first task to design, and they just wanted to train me. They didn't take it very serious, but I remember that I changed the design completely. Instead of using forced air system, I proposed using air washer, system for ventilation of the air for cooling and heating. And when I presented for the first time, I remember my supervisor said that I just gave you this task to kind of have some practice and training, but we didn't take it that serious at that time. But it seems that what you offer is a serious thing, and we need to consider it. I was very proud at that time, although I had a lot of, for sure, as my first design, it was a lot of mistake, a small mistake maybe, or because of lack of experience, but I never forgot the moment, that I had after my presentation.
Awesome. So I'm sure in your career as an engineer, you've met a lot of people. So what would you say is the top soft skill a mechanical engineer must have? So is it creativity? Is it critical thinking? What would you say, in your opinion, is the most important?
It's a really good question. So mechanical engineer are called the people who run the world.
Absolutely,
in my opinion.
Yeah.
We make a common people life, easier and provide them comfort. So this is a kind of very important responsibility, and we should have required the skills to do so. Personally, I think that the passion for creating, maintaining a new product or tools can be listed for sure. More general answer, I can say the skill to use the creativity and mathematics in practical and real world.
Right. Okay.
So being mechanical engineering, in my opinion, requires a high level of creativity for sure. As a mechanical engineer, we should know how not to rely on the way things have been done before. We should be creative. So the first wheel, the first compass, the first aeroplane, all of these, they're very engineered solution, which advanced, human progress. And, that's why, creativity for sure is a must for an engineer.
Well, what skill would you say you've learned recently in terms of engineering?
In my career as a professor, so I'm working with a group of young researcher students, with my colleagues, and I'm involved in, for sure, different projects at the same time. It's not like for example, PhD student or master student that I had my own project to work with. So that's why I learn more about the management skill, quality engineering. Working with industry helped me to understand more about the practical aspects of quality engineering and project management. For example, the idea of using statistical tools and methods to develop or mass produce high quality goods and avoid the high cost of low quality return or early maintenance. These are the new things that I learned. And I'm going to tell you something. In working in engineering world, is every day is every day is a learning day. There are a lot of reaction. There are a lot of feedback. There are a lot of it's a kind of it's like a cycle. Whatever you design, whatever you propose, you receive some feedback. You learn something from it, and every day I learn something new.
Yeah, cool. All right. So our next question, what was your most successful engineering project that you've been a part of, or maybe that you led?
Working in nanotechnology for nanofabrication related, I have been working in that field for maybe 15 years. So as I said, we use laser for nano fabrication, for nanotechnology, related project. So one of the projects that we had is fabrication of nano wires of silicon for new generation of the sensors. Because when we talk about the sensors, each sensor has a sensing structure or device. So and the surface of the sensor is very important. For example, in, let's say, CO or a smoke detector, we have a small sensing surface which is supposed to detect the early particle of the smoke or the first molecule of the CO. So having the high surface area or large surface for interaction with the sensing surface and media environment is very important. So the method that we had for fabrication of nano network silicon, we share the result with our industrial partner. They really like it, and our method is now commercialized. And I can see that people are using it in sensor fabrication. At least this is the plan of the company, to use it in their own product in the near future. This is something that whenever I think about it, I become very proud, and I'm really amazed about it for sure.
Yeah, that is an amazing achievement to have, and definitely impacts a lot of people. But in a team setting, in a project setting, would you prefer working with a team or solo?
We all know about the proverb said that teamwork make the dream work.
Yeah.
Mm-hmm.
And nowhere is it more crucial and maybe important within an engineering, project. So when we talk about teamwork, so I think first of all we have to define it exactly. What does it mean in engineering projects? So to me, having a balanced, effective team or members in the team, and also the team should ideally be cross-functional in its nature. So when you have the combination of balanced team member, and cross-functionality, you have a perfect team. So for the engineering process, again, in my opinion, this is the hybrid process when it comes to working in a team or even alone. Engineering method is strongly rooted and inspired by project management principles. So it means that it requires different stages and milestones. And these milestones may need brainstorming or feedback as their mandatory steps. So when you are dealing with a real world problem, when you want to find a solution for the real world problem, you need to talk to the consumer, operator, different level of users and people who are dealing with. So as I said, most of our research activities that we have has an application in other fields, for example, in biomedical engineering, in chemical sensor fabrication, in advanced manufacturing, in material science, and in our daily activity in our lab. We are meeting people, we have, a conversation with people in different disciplines. Sometimes we don't understand their language, sometimes they don't understand our language well, but this is something also that we have to overcome, to find a way, to communicate.
Yeah, I'm sure it'd be helpful to have like multiple group members if you're trying to communicate with, consumers in that sense.
Yes, exactly.
All right, so we have a lot of students in our audience, so I think this following question is really important. So how would you explain a complex engineering design or concept to a non-technical person, to someone who doesn't really have a lot of experience in the field of engineering?
Engineers, like doctors, like other professions, have their own lingo and terminology for sure. it is very important to be aware of this when we are talking to members of public, or as I just said, explain about the research project that we have. I'm working with biologists, for example. So I believe using the simple real life example is the key parameters here, is the, in fact, cornerstone of any good explanation and elaborations. We try to avoid acronyms and jargon for sure. We should be concise. I mean, you'll need to teach your audience, for example, or explain to your audience some new concept that is far from their field of, study, profession, or research. It doesn't mean that we need to undersell the complexity of what we are explaining, but we should try to get to the point as quickly as possible. And as I said, using a real life example, simple real life example, is very important.
Yeah. So, in general, what would you say are the most common ethical issues or dilemmas that an engineer might face?
Really good question. We live in a business-oriented world. And for sure, the cost efficiency is number one priority when it comes to the design and developing system or products in any industry, in any services. So this may put a pressure on the engineers who are responsible to design, to maintain, inspect, and perform many other activities. So sometimes, finding a balance is difficult. But as a good side, we see actually that the businesses has started to understand the cost of the low. The cost of the low quality due to the early maintenance, for example, and also their reputation because of the competition, because of all those competition nowadays. Reputation is important, so they know that. The cost of the low quality, could be very expensive for a company.
Yeah, absolutely.
So I should also mention role of professional engineering society to mandate some of the must requirement in terms of technical and ethical aspects. For sure.
Oh, interesting. So what is that? Can you provide maybe a little bit of an overview as to what their purpose is?
In professional engineering society, for example, there are some code, some, let's say, rule and policy that they mandated, for example, in different aspects of the industry. For example, let's say in construction industry, there are a minimum code that they need to follow for the foundation of the building, for electrical works or piping, work in the building, and all those requirements, all those codes are in fact developed, proposed, and mandated by the professional engineering. So kind of it helps to have a balance that everything is not about the cost of the manufacturing or the cost of the project. We need to consider high quality, maintenance, safety, and in fact, actually, in long term, even in short term, we save more if we follow, those instructions.
And you mentioned earlier that you've worked in and you studied in multiple countries. So would you say that these rules differ, or are they just universal?
The logic, for sure, or let's say the foundation is the same. Ethics or rules in engineering. In fact, there are not big changes between country to country, except there are some minor things because of the environment, because of the weather condition. Let's say, for example, in Iran, the power outage was 220 volts. Here is 110 volts. Different amps, so that's why it affects, on the other, on the safety, for example, aspect of it, of wiring. In piping, also the same thing. But the main, or let's say the foundation, is the same.
Okay, interesting. All right, so obviously you've been in the field of engineering for a really long time. So is there an aspect that you do not enjoy as much in engineering?
Yeah, as I mentioned, the emphasis on cost efficiency issues
Right. Okay.
as a, I mean, as a constant, burden. Sometimes, it's really difficult, to find a balance point.
Uh-huh.
In fact, finding this balance point is not always enjoyable, or sometimes even it's not possible. So low quality in design and production outputs eventually result in high cost of maintenance and bad reputation, as I mentioned before. So, but yeah, this is maybe the constant burden, something that is not enjoyable always.
So our next question is, what are some of the benefits in working in the world of academia as opposed to the private sector?
Yeah, working with a student who are passionate about their engineering field is always fantastic. Working in academia, again, give me this freedom to kind of, switch my research area, my engineering work, or engineering project that we have. For example, if I have a good idea, or if I hear about some good idea, I can define it as a capstone project for the student. I can ask some passionate student to come and work on it. Again, this is not about making a profit. This is about the learning process. That's why I really enjoy, that flexibility, that freedom. And again, working with young people is amazing. Energetic people, young people. I feel that actually this is the best opportunity, for me, that I didn't thought about it before, become a prof.
So you could say that in the world of academia, it's kind of used for research and to progress knowledge in the field of engineering, whereas in the private sector, it's more using your knowledge in order to create profit. Could you kind of correlate those two?
Yes, yeah, this is exactly what I meant. And again, the freedom that we have in academia is different from, because as I said, you tell me a good project, I'm gonna, I can start working on it. I can, ask some student to join, and work on it. It's not about, making a profit for university. It's about, the main profit for us is learning, or high quality person that we train in our, program.
They're definitely rewarding in their different ways. Yeah.
All right. So do you ever use your skills as a mechanical engineer in your day-to-day life?
Yeah, for sure. I think being engineer kind of, change our vision and our mindset to
you see things in a different way.
Yeah. So, for example, I have something on my top of this. Recently, we moved to a new house, and one of the things that I was considering is if I need to change the windows and doors to high efficiency one. So when I talk with companies, they say, yeah, this is 70% efficient, or this one is 60%. I thought that, okay, 70%, 80% efficiency, it doesn't mean that I'm going to save 70%, 80% on the energy consumption.
Right.
Although they said, because I said, I was working in HVAC or ventilation, engineering for many years. So I started to do my own calculation. Okay, so number of windows that I'm going to change. This is the efficiency of the windows in terms of losing temperature or heat. Then I found that, okay, by changing those windows, I may save something around 10% on the hydro bill. But if I combine it by doing a new isolation for the basement walls, exterior walls, I can increase it to 30%, and that's why this is what we did recently.
Yeah, it's really amazing that you can look at the world around you and use your mechanical engineer brain to sort of, find solutions to everyday problems.
Yeah.
So were there any other engineering fields that you considered before going the mechanical route?
Yeah, I love mechanical engineering, but I should say that industrial engineering and its focus on designing better supply chain system and approaches in the mass production, this is something that
Yeah, they're quite similar. Could
Yeah,
you?
yeah, and question because manufacturing, mechanical engineering is part of it, yeah. And how can, for example, we can develop a supply chain roadmap from a raw material to manufacturing, from raw material supplier to final destination, finally see the finished product in the hand of consumer. So the whole roadmap that mechanical engineering is part of it, yeah, is something that's really interesting about.
Absolutely.
Great. So, do you have any future aspirations or career goals that you would be interested in pursuing?
Yes, certainly. Uh, After the physical reopening of the university, for sure, I would like to initiate and encourage my students more to work with the industry
Mhm.
again. And also, we have a couple of good projects that the initial result they were very promising. I'm trying to encourage my students to uh, consider it as a startup, maybe company, because yeah, they put a lot of effort, a lot of dedication toward that project, and this is always amazing to see what we are doing in the lab, what we are publishing as a paper. It's very amazing to see that, okay, it solved a real world problem. It is a real product. And this is something that people use it because, uh, yeah, fundamental research is crucial, is vital, but at the end of the day, those ones should be applied in our real or day-to-day life. So that's why, I'm now considering, working with the industry more or commercialize a couple of our products, uh, with my students.
The journey from start to finish and seeing your products become truly applicated in real life is definitely something that's extremely rewarding.
Yeah, yeah, and that's really amazing. And very, kind of, very satisfying. You see, when you see that, okay, you did something, you solve a problem, and people use it, consumer use it, and appreciate it. I mean, this is, I think, the best thing in engineering.
Right. And you get to inspire your students, you get to inspire them to also create products of their own, which is
Yeah,
amazing.
yes. Thank you.
So our final question is, what are some tips that you could give for students like us in high school looking to pursue a career in mechanical engineering?
Uh, my advice, my tip to your audience, to the student is please notice mechanical engineering thought is very practical, but it's based on your secondary school courses such as math or physics.
Yeah.
You may also, need to spend several hours per day with relevant software behind the computer in your uh, career as a mechanical engineer later. So my suggestion is to be aware of these things and think about your experience with these courses or subjects. So students are often hesitant to taking sometimes, to taking mechanical engineering because they think that, okay, there are a lot of people opt for mechanical engineering, so there will be more competition. But the actual scenario is that there are a lot of opportunity and career options also available. From medical engineering, from production, R&D, design, power plant, piping, biomedical engineering, automobile, and so on. So also there are a lot of scope for higher studies. As being a vast subject, there are a lot of opportunity for higher studies to do master or PhD in mechanical engineering, for sure.
Okay, well, Professor Kiani, thank you so much. That's like really great insight that I think our listeners will definitely benefit from. But unfortunately, we reached the end of this STEMPOWER episode. Sid and I would like to thank you so much for this opportunity to speak with you.
This is my pleasure, and thank you for the opportunity.
Thank you all once again for listening to this episode of STEM Power, and we hope you stay tuned for the next one.